Welcome to the Cyber Operations and Risk Management briefing for Charles Fleischer of Team New Zealand. First, a brief background of the situation. Recently, the Five Eyes Summit was hit with a ransomware attack which affected several computer systems. When attendees attempted to log into their computers, they were met with a screen which explained that their systems had been locked by the FBI and Justice Department due to involvement in child pornography. These messages demanded payment for $500 in Bitcoin for the return of control of their systems. This brief will focus on discovering the vulnerabilities which may have led to the ransomware attack and ways in which to remediate those risks. This ransomware attack wreaked havoc on the summit by crippling the ability of the staff to perform work on their computers. The choice was either to pay $500 per workstation which was affected or lose all the data contained on those systems and give them a fresh operating system installation. There are a number of possibilities as to how this ransomware was able to infect our systems. First, there may be vulnerabilities within the supply chain. Often supply chains extend through various companies and nations before the product reaches its final destination. Examining and securing the supply chain is vital to cybersecurity. Second, there may be vulnerabilities within existing systems. Current systems may be lacking in their security, so a review of current systems is necessary to determine what may be done to prevent future ransomware attacks. Third, developing software assurance is important for New Zealand because other members of the summit may be affected by our mistakes. Implementing policies for software assurance will be important for all members of the Five Eyes. Finally, the system development lifecycle may be lacking a security component. The most common way for an attacker to infiltrate a system is through a flaw in software. These flaws may inhibit the software's capability, may not inhibit the software's capability to function properly, but they can lead to security vulnerabilities. Incorporating security into the SDLC is vital to developing a secure product. The supply chain has the potential to be a major security risk. Each piece of equipment may have multiple components sourced from various countries around the world. These components may have subcomponents which have been sourced from even more countries. Some companies in foreign nations, which are known for producing electronic components like China, could pose a potential risk due to their ability to insert physical or software vulnerabilities into their components, which then get included in a wide range of products. This makes the entire supply chain very difficult to see from a macro level and all the interactions that take place to bring a product to our door. Additionally, there is always the potential for tampering in transit. Many devices are shipped via cargo vessel, which spend months at sea. There is plenty of time between the end of the manufacturing line to the receiving destination when an individual may attempt to tamper with a device. Finally, when a device is accepted by the company, there is little to no scrutiny of the device and what it may contain. Those devices are often trusted when in fact there may be potential for security concerns. Analyzing the supply chain may be difficult. However, it is a necessary step to securing the supply chain. Prior to selecting a vendor for a device, vet that vendor and examine their operation. Although they may have the cheapest price, there could be problems underneath the surface. Find sources with good reputations for using trusted components. Knockoff components make the manufacturing of devices much less expensive, but these are often the type of components which may contain a security vulnerability. Examine incoming devices and sanitize them with forensic software tools. Forensic software can reveal any malicious code lurking on a new device and eliminate it before the device enters the network environment. Another possibility for how the network was infected with ransomware is the vulnerabilities which may exist on current systems. There are a variety of ways that current systems may be vulnerable. The most common offender for current software vulnerabilities is unpatched software. Unpatched operating systems are a notorious problem which must be addressed. Unpatched application software, akin to operating system software, also poses a similar security vulnerability which is easily remedied. Unpatched web browsers could have allowed the ransomware to enter the systems through the course of normal web browsing. Patching software is vital to a security because patches keep those systems up to date with the latest security flaws which have been discovered for those softwares. Implementing routine patching policies is a key component of a strong security posture. Aside from unpatched systems, there may be other weaknesses in system software. The intrusion detection system may be configured poorly, which wouldn't allow it to identify the type of traffic the ransomware was using. This system should be reconfigured as soon as possible and updated to ensure that it can capture any malicious activity. Additionally, the identity and access management system is not using two-factor authentication, which would have allowed an attacker to remotely gain access to our systems. Upgrading to a two-factor authentication system will ensure that our company falls in line with a recognized industry best practice and will ensure that only the right people access the right systems. Going forward, we should seek software with a level of software assurance. Software assurance is a level of confidence in the software to operate as designed and be free of vulnerabilities, either intentionally or unintentionally incorporated into the program. Every organization should expect that the software they purchase for their business operations doesn't create a new vulnerability in their cybersecurity posture. The Software Engineering Institute estimates that 90% of reported security incidents result from exploits against defects in the design or code of software. Ensuring software integrity is key to protecting the infrastructure from threats and vulnerabilities and reducing overall risks to cyber attacks. To minimize this and ensure that software assurance can be achieved, our company and those that we purchase software products from should be building security into their software in the system's development lifecycle. This way, security is considered throughout the development of the product and not just added as a patch once a vulnerability has been discovered by a cybersecurity firm. Building software assurance requires a new perspective on software development. Software should be designed from the onset with security in mind rather than considered as an afterthought which can be implemented as a patch in the future. Security needs to be a focus throughout the course of the software development lifecycle. Developers and users alike will require training to think with a security focus. Additionally, best practices and guidelines should be put in place for secure software development. An analysis of the tools used for evaluating the vulnerabilities of the software and their quality is important to detecting any vulnerability during the development phases. When acquiring software from a third party, specifications and guidelines for acquisitions and outsourcing of risk should be implemented in policy to assure software assurance. The systems development lifecycle has various models. Each model has its strengths and weaknesses, which range from fast production with more flaws to slow production with less flaws. Depending on the type of software being developed, each one has its merits. However, one thing often overlooked in the software development lifecycle is security. Developers are understandably more focused on making their program work without errors rather than ensuring that their program is difficult to attack. This is a lack of foresight, and although it may extend the development time and cost of a product, thinking of the security ramifications of the software is an important inclusion from the very beginning of development. Each phase of the software development lifecycle has some important security aspects to consider. In the requirements and design phase, developers should be thinking about any requirements their software may have in terms of resources needed for security. They should also be thinking about how they can harden their software against common attacks like SQL injection or scripting attacks, which may trick their program into giving away valuable information. In the coding phase, developers should be implementing secure coding techniques which harden their code against these attacks and include features to thwart cyber attacks. In the testing phase, not only the functionality of the software should be tested, but also the security of that software. This testing will help to reveal any potential vulnerabilities prior to the deployment of that software. Finally, once the software has been released, continuous monitoring of the software should continue so that if there were any vulnerabilities which did slip past the other phases, they can be quickly patched and pushed to customers. Although patching should be a last resort, not the standard practice as it is often today. Many of these remediations are effective at mitigating the potential for another ransomware attack from happening, but with security, there is often a great cost. Cybersecurity is an expensive prospect for many companies and governments, not only in the initial cost of setting up security, but also in maintaining it. Depending on the size of the organization, a basic cybersecurity infrastructure can cost anywhere from a few $1,000s well into the hundreds of millions of dollars. The best and cheapest place to start to improve security is applying updates and patches to current systems and replacing vulnerable ones. This can be done easily as software patches are free of charge, and swapping out older systems with newer ones is easily done at a minimal cost. Implementing total supply chain security can be very expensive in both labor and time. So an easy way to minimize the risk is to use trusted suppliers with solid reputations for secure hardware. Although it may be more expensive than the lowest bidders, but their products will be safe to use. Achieving total software assurance from our vendors will increase the price of that software substantially. Software produced by us will take a much longer time to create due to the addition of security into the software development lifecycle and increase its overall price. Although good security comes at a price, the price is ultimately outweighed by the prevention of an attack. This cost savings is often hard to measure because it is never seen. When an attack does happen, it is easy to calculate with the millions lost. But when an attack is prevented, there is no way to calculate the savings. The ransomware attack, although damaging, has revealed gaps in our cybersecurity that needed to be addressed. There are a few key lessons which can be learned from this incident. There is a potential risk in the supply chain which can be reduced by selecting a trusted vendor for important components. Reviewing our current systems has revealed vulnerabilities which can be easily fixed, and policy can be altered to ensure that they remain secure. Software assurance is important not only for our company, but also for all the Five Eyes Summit attendees. Implementation of secure software development is vital for new projects moving forward, and the cost of cybersecurity is ultimately worth it when compared to the potential for high costs of non-implementation.